Hello, in this lecture we'll find out the value of angle theta. In the drawing we have triangle ABC, side AC equal to side BC, that is to say triangle ABC is an isosceles triangle. In addition, we know that angle ACB equals to 20 degrees in its size, angle NAB equals to 50 degrees, and angle NBA equals to 60 degrees. Our mission is to find out the value of angle NMB, this angle that is actually defined as angle theta. So first of all, I will copy triangle ABC in a new page and we will analyze it. Actually, this is triangle ABC, the copy from the original drawing. Side CA equals to side CB, and this angle ACB equals to 20 degrees in its size. Those two sides are equal to each other, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And the sum of the angles in any triangle is equal to 180 degrees. So in triangle ABC, theta plus theta, that is 2 theta, plus 20 degrees must be equal to 180 degrees. So 2 theta plus 20 degrees equals to 180 degrees. We subtract 20 degrees from this equation, and you get that 2 theta equals to 180 minus 20 degrees. It is 160 degrees, so 2 theta equals to 160 degrees. We divide this equation by 2, and finally you get that angle theta equals to 160 degrees over 2, it is 80 degrees. Angle theta equals to 80 degrees in size. This is angle theta, that is also equals to 80 degrees. So in the original drawing, we have this is angle theta that is equal to 80 degrees. But part of angle theta, that is to say angle NAB, it is already equals to 50 degrees, therefore the missing angle must be equal to 30 degrees. Again, in order to complete the size of this angle theta to 80 degrees, the missing angle must be equal to 30 degrees. Likewise, this is angle theta that is equal to 80 degrees. But part of angle theta, that is to say angle MBA, it is already equal to 60 degrees, therefore the missing angle must be equal to 20 degrees. In order to complete the size of this angle theta to 80 degrees, the missing angle here must be equal to 20 degrees in its size. In the next step, we focus on triangle A and B. So I copy triangle A and B in a new page and we will analyze it. Angle NAB equals to 50 degrees, and this is angle theta that is equal to 80 degrees. So actually, this is triangle A and B that I copied from the original drawing. We define the missing angle is theta. The sum of the angles in triangle A and B must be equal to 180 degrees. That is to say 50 degrees plus 80 degrees plus the missing angle theta. In total, the sum of those three angles must be equal to 180 degrees. 50 plus 80 is 130, so 130 degrees plus theta equals to 180 degrees. We will subtract 130 degrees from this equation, and finally we get that angle theta, the missing angle theta equals to 180 minus 130, it is 50 degrees. So this is angle theta that is equal to 50 degrees. Angle theta, it is actually angle A and B, so angle A and B equals to 50 degrees in its size. We write it down in the original drawing, that is angle A and B equals to 50 degrees in its size. We continue to focus on triangle A and B. In triangle A and B, those two angles are both equal to 50 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, they are equal sides. So in front of those two equal angles, we have those two sides that must be equal to each other. That is to say, side AB equals to side NB. AB equals to NB. So I write it down here. That side AB equals to side NB. And also side AB equals to side NB. Okay, so in the next step, we focus on triangle A and B, this triangle, so I copy triangle A and B in a new page and we will analyze it. Angle MAB, this angle equals to 80 degrees, and angle MBA equals to 60 degrees. So actually, this is triangle A and B that I copied from the original drawing. We define the missing angle as theta. The sum of the angles in triangle A and B must be equal to 180 degrees. That is to say, 80 degrees plus 60 degrees plus the missing angle theta. In total, the sum of those three angles must be equal to 180 degrees. With 80 plus 60 is 140, so 140 degrees plus theta equals to 180 degrees. We subtract 140 degrees from this equation. Finally, we get that angle theta, the missing angle theta equals to 180 minus 140, it is 40 degrees. So this is angle theta that is equal to 40 degrees in its size. Angle theta, it is actually angle A and B. So angle A and B equals to 40 degrees in its size. I write it down here. That this angle A and B equals to 40 degrees in its size. So, in the next step, we will do a construction. That is to say, from point B, we draw line segment BD on CA in such a way that BD will be equal to BA. Again, BD will be equal to BA according to our construction. So, this is line segment BD that we constructed, and we constructed line segment BD in such a way that BD equals to BA. So I write it down here. AB equals to BD. So here we have two equations. For one side, AB equals to NB. From the other side, AB also equals to BD. So we can write here that AB equals to BD. And from this equation, AB equals to BD, we will derive that NB equals to BD. So here, BD equals to NB. In the next step, we'll focus on triangle ADB, this triangle. So I'll copy triangle ADB in a new page and we will analyze it. This again equals to 80 degrees in its size. Side AB equals to side DB according to our construction. So actually, this is triangle ADB that I copied from the original drawing. I repeat again that side AB, this side equals to side DB according to our construction. Again, we have the same rule that in front of those three equal angles, in front of those three equal sides, there are equal angles. So in front of those three equal sides, we have those two angles that must be equal to each other. But this angle is equal to 80 degrees, therefore the other angle must be also equal to 80 degrees in its size. That is to say, this angle ADB equals to 80 degrees in its size. I write it down here, that this angle ADB equals to 80 degrees in its size. We continue to focus on this triangle ADB. In triangle ADB, the sum of the angles must be equal to 180 degrees. We define the missing angle as theta. So 80 degrees plus 80 degrees plus theta. In total, the sum of those three angles must be equal to 180 degrees. 80 plus 80 is 160, so 160 plus theta must be equal to 180 degrees. We subtract 160 degrees from this equation, and we get that theta equals to 180 minus 160, it is 20 degrees. So the size of this angle theta is equal to 20 degrees. Okay. That is to say, angle theta is actually angle ABD. Angle ABD. So angle ABD equals to 20 degrees in its size. So I write it down here. This is angle ABD. That is equal to 20 degrees in its size. So here we have the small angle DBA, it is equal to 20 degrees in its size. The big angle is angle MBA. The big angle equals to 60 degrees in its size. So the big angle MBA minus the small angle DBA must be equal to the missing angle MBD. Okay, the big angle minus the small angle equals to the missing angle MBD. So I write it down. The big angle is angle MBA. That is equal to 60 degrees in its size. Minus the small angle, that is actually angle DBA. That is equal to 20 degrees in its size. So the difference between the big angle and the small angle must be equal to the missing angle MBD. repeat again. The big angle MBA that is equal to 60 degrees in size minus the small angle DBA that is equal to 20 degrees in size must be equal to the missing angle MBD. So 60 minus 20 is 40. We found out that the missing angle MBD equals to 40 degrees in its size. So actually, this is the missing angle MBD, it is equal to 40 degrees in its size. In the next step, we focus on triangle MDB. So we copy triangle MDB in a new page and we will analyze it. We just right now found out that angle DBM equals to 40 degrees in its size. And we already found out that angle DMB is also equals to 40 degrees in its size. So actually this is triangle MDB that I copied from the original drawing. Those two angles are equal to each other. Again we have the same rule. That in front of equal angles in the triangle, they are equal sides. So those two sides that are located in front of those two equal angles must be equal to each other. That is to say, dm equals to db. Okay, so I write it down here. The dm equals to db. And also, this is side dm. Is equal to side dB. Okay. In the next step, we join points D and N together with a straight line. And we will focus on triangle DNB. And again, we focus on the green triangle, triangle DNB. So I copy triangle DNB in a new page and we will analyze it. Angle NBD, this angle NBD, very easy to see from the drawing, that angle NBD, this angle is equal to 40 degrees plus 20 degrees, that is 60 degrees. And side DB equals to side NB. Here, side DB equals to side BD, side NB equals to side BD, NB equals to BD. So actually, this is triangle NBD that I copied from the original drawing. I repeat again that angle NBD equals to 60 degrees and side NB equals to side DB. Again, we have the rule that in front of equal sides in the triangle, there are equal angles. So those two sides that are equal to each other are located in front of those two angles that must be also equal to each other. So if this angle is theta, then the other angle must be also equal to theta, and the sum of the angles in triangle DNB must be equal to 180 degrees. So theta plus theta is 2 theta. 2 theta plus 60 degrees must be equal to 180 degrees. We subtract 60 degrees from this equation, and we will get that 2 theta equals to 180 minus 60, it is 120. So 2 theta equals to 120 degrees, we'll divide this equation by 2, and finally we get that angle theta equals to 120 degrees over 2, it is 60 degrees. So this is angle theta that is equal to 60 degrees inside, and this angle theta is also equal to 60 degrees inside. So we found out that inside triangle NDB we have three angles that all of them are equal to 60 degrees in their sizes. Therefore triangle NDB is an equilateral triangle. So I write it down. Triangle DNB is an equilateral triangle. And we also know that all the sides in any equilateral triangle are equal to each other. That is to say, side DN equal to side NB equal to side DB. So I write it down. Side DN equals to side NB equals to side DB. DN equals to NB equals to DB, the green equilateral triangle, triangle NBD. So we focus on those two equations. For one side, dB equals to dm. Yeah, dB equals to dm. But from the other side, from this equation, we derive that dB also equals to dn. So we can write here that dB equals to dn. And from this equation, dm equals to dB equals to dn, we will derive the dm equals to dn. dm equals to dn. Here, side dm equals to side dn. Okay. In the next step, we focus on the straight line CA. In this side of the straight line CA is point D. So, which angles we have on this side of CA at point D? We have this angle ADB is equal to 80 degrees. We have also this angle NDB, it is one of the three angles of the equilateral triangle NDB, therefore it must be equal to 60 degrees. So, actually, this is the straight line CA. We have on this side of the straight line CA, it's point D, we have this angle that is equal to 80 degrees plus this angle that is equal to 60 degrees. 80 plus 60, it is 140. The sum of those two angles is in total they are equal to 140. Therefore, the missing angle must be equal to 40 degrees. In order to complete the sum of the angles from this side of the straight line CA point D to 180 degrees, the missing angle must be equal to 40 degrees. So actually, this is angle MDN that is equal to 40 degrees in its size. I write it down here, angle MDN equals to 40 degrees in its size. Here, angle MDN equals to 40 degrees in its size. The next step, we focus on triangle MDN. So I copy triangle MDN in a new page and we will analyze it. Again, MDN equals to 40 degrees in its size. And side MD equals to side DN. So actually, this is triangle MDN that I copied from the original drawing. Angle MDN equals to 40 degrees in its size. And DM equals to DN. Repeat again. Found out that DM equals to DN. So those two sides are equal to each other. Again, according to the same rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And the sum of the angles in triangle MDN equals to 180 degrees. Theta plus theta is 2 theta plus 40 degrees. In total, the sum of those three angles equals to 180 degrees. We subtract 40 degrees from this equation. And finally, we get that 2 theta equals to 180 minus 40, is 140. So 2 theta equals to 140 degrees. We'll divide this equation by 2. And finally, we get that angle theta equals to 140 over 2, it is 70 degrees. So angle theta equals to 70 degrees in size. This is angle theta that is equal to 70 degrees. Angle theta, it is actually angle DMN. Found out that angle DMN equals to 70 degrees in size. So the big angle, angle DMN, equals to 70 degrees in its size. This is the big angle. So the big angle NMD or DMN is equal to 70 degrees in its size. Minus the small angle DMB that is equal to 40 degrees in its size must be equal to the missing angle, angle theta. So I write it down. The big angle is angle DMN that is equal to 70 degrees in its size, minus the small angle that is actually angle DMB. That is equal to 40 degrees in its size, must be equal to the missing angle, angle theta. Angle theta is also defined as angle NMB. Repeat again. The big angle DMN that is equal to 70 degrees in size minus the small angle DMB that is equal to 40 degrees in size must be equal to angle theta. So 70 minus 40 is 30 degrees. So I found out finally that the missing angle theta that is also equal to, it is defined as angle NMB, it is equal to 30 degrees in its size. And that is the answer to our question. This is angle theta is equal to 30 degrees in size. So In the next step, I will summarize the lecture. In this lecture, we found out the size of this angle theta that is also defined as angle NMB. We have here triangle ABC is an isosceles triangle because side CA equals to side CB. This angle ACB equals to 20 degrees inside. This angle NAB equals to 50 degrees inside. And this angle MBA equals to 60 degrees inside. Our mission is to find out the size of this angle theta. So first of all, I'll copy triangle ABC in a new page and we analyze it. So actually, this is triangle ABC that I copied from the original drawing. Angle ACB equals to 20 degrees inside, and those two sides are equal to each other. So CA equals to CB, and we have the rule that in front of equal sides in the triangle they are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if one angle is theta, then the other angle must be also equal to theta. Okay? And we know that the sum of the angles in any triangle is equal to 180 degrees. So theta plus theta is 2 theta, and 2 theta plus 20 degrees must be equal to 180 degrees. We subtracted 20 degrees from this equation and finally found out that 2 theta equals to 180 minus 20, it is 160. So 2 theta equals to 160 degrees. We divided the equation by 2 and finally found out that angle theta equals to 160 degrees over 2, it is 80 degrees. So angle theta equals to 80 degrees in its size. This angle theta, those two angles theta, each of them are equal to 80 degrees in their sizes. So we have here found out that this is angle theta that is equal to 80 degrees in its size, but part of angle theta, that is to say angle NAB, it is already equals to 50 degrees in its size. Therefore the missing angle must be equal to 30 degrees. In order to complete the size of this angle theta to 80 degrees, the missing angle here must be equal to 30 degrees. Likewise, this is angle theta that is equal to 80 degrees, but part of angle theta, that is to say angle MBA, it is already equal to 60 degrees, therefore the missing angle must be equal to 20 degrees. In order to complete the size of this angle theta to 80 degrees, the missing angle must be equal to 20 degrees. The next step, we focus on triangle NAB. So I copy triangle NAB in a new page and we analyze it. This is triangle NAB that I copied from the original drawing. Angle NAB equals to 50 degrees in size and angle NBA equals to 80 degrees. Okay, and the missing angle is theta. The sum of the angles in triangle NAB must be equal to 180 degrees. So 50 degrees plus 80 degrees plus the missing angle theta, in total they must be equal to 180 degrees. 50 plus 80 is 130, so 130 degrees plus theta must be equal to 180 degrees. We subtracted 130 degrees from this equation and finally found out that the missing angle theta is 180 minus 130, it is 50 degrees. This is the missing angle that is equal to 50 degrees in size. Angle theta is actually also angle NAB. So we can write down in the original drawing that this angle NAB equals to 50 degrees in its size. We continue to focus on triangle A and B. In triangle A and B, we have those two angles that are equal to each other. And we have the rule that in front of equal angles in the triangle are equal sides. So those two sides that are located in front of those two equal angles must be equal to each other. That is to say, side AB equals to side NB. Again, side AB equals to side NB. And write down here that side AB equals to side NB, and also here side AB equal to side NB. Then we focus on triangle MAB, so I call it triangle MAB in a new page and we analyze it. This is triangle A and B that I copied from the original drawing. This angle MAB equals to 80 degrees, and angle MBA equals to 60 degrees, 80 and 60. So we define the missing angle as theta. The sum of the angles in triangle AB equals to 180 degrees. That is to say 80 degrees plus 60 degrees plus the missing angle theta. In total, they must be equal to 180 degrees. 80 plus 60 it is 140, so 140 plus theta equals to 180. We subtracted 140 degrees from this equation, and we found out that the missing angle theta equals to 180 minus 140, it is 40 degrees. So this is angle theta that is equal to 40 degrees in its size. That is angle theta is defined also as angle AMB that is equal to 40 degrees. This is angle AMB that is equal to 40 degrees in its size. Okay. In the next step, we focused, we actually did a construction. From point B, we draw a line segment in such a way. We draw line segment BD on C. We draw line segment BD on CA in such a way that line segment BD will be equal to line segment BA. Okay, BD equals to BA according to our construction. Okay, and then I copy triangle ADB in a new page and we analyze it. This is triangle ADB that I copied from the original drawing. This angle equals to 80 degrees. This angle DAB equals to 80 degrees. Again, those two sides, that is to say AB equals to DB according to our construction. Okay, note down that AB equals to DB according to our construction. So here we have on one side AB equals to NB. But from the other side AB also equals to BD, so can I do that AB equals to BD, and from this equation NB equals to AB equals to BD, we will derive that NB equals to BD. NB equals to BD. Here, side N, this is side NB, that is equal to side BD. Okay? So, continue with triangle ADB. So, AB equals to BD according to our construction, and this angle equals to 80 degrees. This angle equals to 80 degrees. Those two sides are equal to each other according to the same rule. In front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. But this angle equals to 80 degrees, therefore the other angle must be also equal to 80 degrees. That is to say angle ADB equals to 80 degrees in size. This is angle ADB that is equal to 80 degrees in its size. We continue to focus on triangle ADB. In triangle ADB, the sum of the angles must be equal to 180 degrees. That is to say 80 plus theta must be equal to 180. 80 plus 80 is 160. So 160 degrees plus theta must be equal to 180 degrees in triangle ADB. We subtracted 160 degrees from this equation and finally found out that angle theta equals to 180 minus 160 is 20 degrees. So this is angle theta that is equal to 20 degrees in size. Angle theta is actually defined also as angle ABD that is equal to 20 degrees in its size. So here, this is angle APD, this angle equals to 20 degrees in its size. Okay, so here we have the small angle ABD equals to 20 degrees in its size. The big angle MBA, the big angle is MBA, that is equal to 60 degrees in its size. So the big angle MBA minus the small angle DBA must be equal to the missing angle MBD. Again, the big angle MBA minus the small angle DBA must be equal to the missing angle MBD. So repeat again. The big angle MBD that is equal to 60 degrees in its size minus the small angle DBA that is equal to 20 degrees in its size must be equal to the missing angle MBD. 60 minus 20 is 40, so I found out that the missing angle MBD must be, it is equal to 40 degrees in its size. So this angle MBD equals to 40 degrees in its size. So in the next step we focus on triangle MBD. So I copy triangle MBD in a new page and analyze it. This is triangle MBD that I copied from the original drawing. We just right now found out that angle MBD equals to 40 degrees. And we already found out that this angle DMB it is also equals to 40 degrees. Okay. Those two angles are both equal to 40 degrees. And side DB equals to side DM. Here. Side DB equals to side DM. Side DB equals to side DM. So those two sides are equal to each other. Again, according to the symbol. Actually, we have here those two angles are equal to each other, and we have the rule that in front of equal angles in the triangle, they are equal sides. So those two sides that are located in front of those two equal angles must be equal to each other. That is to say, side DM equals to side DB. So here you write down that side DM equals to side DB. Okay, here side DM equals to side DB. In the next step, we join points D and N together by a straight line. And we focus on triangle NDB. We focus on the green triangle, triangle NDB. So I copy triangle NDB in a new page and we analyze it. This is triangle NDB that I copied from the original drawing. Angle NBD. This is angle NBD. Here, the big angle NBD equals to 40 degrees plus 20 degrees, it is 60 degrees. Okay? So angle, this is angle NBD that is equal to 60 degrees. And we already found out that NB equals to BD. Here, NB equals to BD. So those two sides are equal to each other. Again, according to the rule, that in front of equal sides in the triangle, there are equal angles. Here, NB equals to BD. Those two sides are equal to each other. Therefore, those two sides must be they are in front of those two equal angles. That is to say, those two angles must be also equal to each other. So if this angle is theta, this angle must be also equal to theta, and the sum of the angles in triangle DSB must be equal to 180 degrees. Theta plus theta is 2 theta, so 2 theta plus 60 degrees must be equal to 180 degrees. We subtracted 60 degrees from this equation, and we found out that 180 minus 60 is 120, so 2 theta equals to 120 degrees. We divided this equation by 2, and we found out that angle theta equals to 120 degrees over 2, it is 60 degrees. This is angle theta that is equal to 60 degrees, and this angle theta equals to 60 degrees. So actually found out that in triangle NDB we have three angles that all of them are equal to 60 degrees in their sizes. Therefore, triangle NDB is an equilateral triangle. Triangle NDB is an equilateral triangle. And we also know that all the sides in any equilateral triangle are equal to each other. That is to say, side DN equals to side NB equals to side DB. Again, in the equilateral triangle, triangle NDB, all the sides are equal to each other. That is to say, side DN equals to side NB equals to side DB. Here we can write down that side DN equals to side NB equals to side DB. We'll focus on those two equations. According to this equation, dB equals to dm. So note here that dB equals to dm. But according to this equation, dB also equals to dn. So we can write here that dB equals to dn. And from this equation, dm equals to dB equals to dn, we will derive that dm equals to dn. Okay, dm equals to dn. Here we can write down that dm equals to dn. Then we focus on this side of the line of the straight line C8 point D. Which angles we have this side of C8 point D? We have this angle that is equal to 80 degrees. Plus this angle that must be equal to 60 degrees because it is one out of three angles of the equilateral triangle NBD. plus the missing angle. So in this side of this certain C8 point D, we have 80 degrees plus 60 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles from one side of a set line is equal to 180 degrees. 80 plus 60, it is 140 degrees, so the missing angle must be equal to 40 degrees in its size. Again, in order to complete the sum of the angles on this side of the set line CA to 180 degrees, the missing angle must be equal to 40 degrees. That is to say, the missing angle, it is angle MDN that is equal to 40 degrees in its size. This is angle MDN that is equal to 40 degrees. In the next step, I'll copy triangle MDN in a new page and we analyze it. This is triangle MDN that I copied from the original drawing. We just right now found out that angle MDN equals to 40 degrees in its size and DM equals to DN. Here we only found out that DM equals to DN. DM equals to DN. Again, according to the same rule that in front of equal sides in the triangle, there are equal angles. So in front of those two equal sides, we have those two angles that must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And the sum of the angles of triangle in the end must be equal to 180 degrees. That is to say, theta plus theta is 2 theta, so 2 theta plus 40 degrees must be equal to 180 degrees. We subtracted 40 degrees from this equation and finally found out that 2 theta equals to 180 minus 40, it is 180 minus 40, it is 140 degrees. So 2 theta equals to 140 degrees. We divided this equation by 2 and finally found out that angle theta equals to 70 degrees in its size. Angle theta, it is actually also angle DMN. It is defined as angle DMN, so we can write down that angle DMN equals to 70 degrees in its size. So here we have the big angle, angle DMN equals to 70 degrees in its size, minus the small angle, angle DMB that is equal to 40 degrees in its size must be equal to the missing angle, angle theta. Again, the big angle DMN minus the small angle DMB must be equal to the missing angle, angle theta. So I repeat again, the big angle DMN that is equal to 70 degrees in size minus the small angle DMB that is equal to 40 degrees in size must be equal to the missing angle, angle theta, that is actually defined also as angle NMB. 70 minus 40, it is 30 degrees. So actually I found out that the missing angle, angle theta, it is also defined as angle NMB equals to 30 degrees in its size. I repeat again, this is the missing angle, angle theta, that is also defined as angle NMB, is equal to 30 degrees in its size. Okay, thank you very much.